It's a pleasure and an honor to be sharing this room with you. I have had in these days, I had these days the opportunity to give sense personally to the developers or the distributors of products that have helped the work of my team, the work of my students. And for the most part, I want to say that I'm very thankful that this work is being done and that allow people all around the world to do really, really interesting work in science that also can be reflected in products that are of service to society. I also want to thank my team, my students, Roberto Del Rio and Eric Campo, and my colleagues from Universidad Tecnológica de Bolívar and Universidad del Norte, Herman and Milton. This work is basically something that is a very simple application of reanalysis WIINs for wave hindcasting, and I'm presenting this case. It's a case study of a wave model that we developed of the Caribbean coast of Colombia, and the reanalysis data that we use were GRA 55 as wind forcing, and I want to give sense to the people in Japan that developed the product, and we use wave boundary conditions from WWIII. I'm gonna give a really, really short introduction. I'm gonna talk about my data, my methods, some results, and the applications and impact that are linked to the work, and also what we are we have been thinking and considering for future work. Basically, we know that there are several limitations here for working in the local scale if you want to do risk management and risk analysis, if you want to really calculate with accuracy sediment transport, longshore currents, for doing actual work of management of the territory and guarantee the quality of life and safety of people. There is a serious issue all around the world, and it's the lack of observational data in things that are very basic, like wave characteristics, sea level, tides. So the beauty of that limitation, the beauty of that problem is that with a little ingenuity, you can use products that are in the global scale and the regional scale, and combining those data with analytical and numerical models, you can actually provide some answers to problems that are between the regional scale and the local scale. So this work is basically about that. And I'm not going to give you a lecture about all the crunching the numbers, because I think that the scope of this section is more to actually see what are the products and what can be done, right? So basically what we did was we used an existing model, the simulating waves near-shore model, SWAN, and basically we use the GR55 winds as an input for forcing of the model, and we put in the boundary conditions of the model the data from WWIII from NOAA, and the comparison of the results of the model we did when very limited information that we had off the coast of Colombia, one weighed buoy here in front of Guajira, in front of Barranquilla, and in front of Turbo, the Urabá Gulf. So with this approach, we follow the classic process that you do for the calibration and verification of a model used for which is intended for wake hindcasting. So you had your data input, you consider boundary conditions that I mentioned, you define a model domain, you had your wind forcing, and then you put that information in a process that is really a lot of work, because you had to do a sensitivity analysis of the physical processes involved. And in this case, we're talking about wake modeling, we're talking about white capping, and the quadruplex formulation. And these processes are very important. White capping is related with the energy dissipation in waves. And the quadruplex formulation is basically talks about the interaction between groups of waves. So how the energy of the waves is transferred from one direction to another. So the physics of this is not trivial, and you need to consider, you can do it in several ways, but what we did was we took the hard and long and painful way. We choose two coefficients for white capping and one coefficient for the quadruplet formulation, and you can do the numbers. You put like 5 choices for one of these and do the combinations. That's a lot of work. And you end up doing those simulations. You had your output data. You compare using, the classical approach of statistics between your observed data and your model data. And, you use the classical tools of statistics for this. And also, you can always put a hand in the old Tyler diagram and compare your results. And we actually found something very interesting related with the physics of the processes, and in this case for the Caribbean coast of Colombia. And we end up with a very nice interpretation for some periods of times, with the limitation of the weight data available, of course, for the 3 points that I mentioned. So this is the Barranquilla buoy, and significant wave height, period, and direction actually gave us a really good match. And that was similar also for the Guajira buoy. And I want to emphasize the importance of something here. All around the world, people really focus in significant wave height because, let's say, for several sectors, risk analysis and energy potential calculation, a lot of things depend on the wave height. But if you want to calculate longshore currents and sediment transport, you also need to get right the period and especially the direction. For longshore currents and for sediment transport, that's very sensitive. So something that we push with our humble model was to really get those parameters right. And for these 2 points, I think that we did a really good job. For the turbo buoy, not that much, and that is due to the fact that you're using a model that, of course, the physics can be well interpreted, well put, but still, you had some limitations, some problems, some issues, and that buoy in particular is close to the boundary condition. It's also in front of a gulf, in front of a bay. So there are processes that are related to the hydrodynamics that we are not still getting. And that's more work for the future, right? So I want to summarize that our results made possible to actually reproduce the main characteristics of the wet climate at the Colombian Caribbean. For us, in the dry season, let's say December through April, we had the influence of the cold fronts, and we capture one of those. Here are the winds. This is the NOAA model, and this is our SWAM model. And also for the rainy season, we were able to capture a couple of tropical storms and hurricanes, and actually getting patterns in terms of the spatial distribution of wave height and the other parameters quite realistic. So we were, well, we were happy until this point. And what we had now is the possibility, given the nature of the input that we had from those databases that are the input for the model, we can reproduce a history of 30 years of waves inside the domain of the model. And we are using those data for doing some energy potential analysis, which is something that we want to take as further as we want. We had some people working in mechatronics and mechanical engineering pushing in that direction when we are helping with our model. And also, we had the chance now that we had these 30 years of data to put this in the context of the analysis of things like long-term trends and climate change. So we think that we had a tool that you can run in a PC, very inexpensive, totally free, using free code and free data, and that is very empowering. Think about the people all around the world that is facing those limitations. So again, thank you. Thank you for giving the people, and I say the people, the opportunity of doing that. So this has a lot of potential for maritime and port activity, naval and offshore activity, coastal risk management, early warning systems, coastal planning, coastal protection design. Of course, it has potential to contribute to resilience and adaptation to climate change, and of course, renewable energy. I want to mention that the part that plays the academics in this is very important. I mean, what you are seeing here are my students of classes that go from time series analysis, coastal engineering, and climate analytics. Those are my master and PhD students. And we are using your data, and we are very happy about it. So if one of those mornings you feel down and you don't feel like going to the office, think about your friends in Colombia, okay? Don't give up. You are doing quite well. And this work has involved in some projects related with water resilience and also coastal risk management. And we had a couple of publications that, in that this model was used. For example, 1 minute? Okay. So, for example, for this analysis of Ciénaga Grande de Santa Marta, that is a Ramsar wetland, quite strategic in terms of biodiversity all around the world. We use the model for the analysis of a comprehensive proposal of nature-basic solutions. And we keep working, in the development of tools that can put this data in the hands of people. Please do read this paper. It's quite simple. The code is available, and basically it's a Python application that use regular people to access weight data of good quality. And we want to keep working in this. And we hope that we can use these tools, these models, this data for improve the spatial and temporal resolution of our risk assessments and explore the interaction of climate with other elements, including socioeconomic, cultural, educational, and disaster risk elements. And we think that it's important to keep working and bridge the gap between the science and the practical applications. And I guess that that's what we're talking about here in this section. So again, thank you very much for the work that you guys are doing. And you now know that you had some friends in Colombia, South America, in Cartagena de Indias, and you are welcome to come and visit. Thank you very much.
Thank you very much.